Yeah. Next topic is shared memory system. Okay. Here, a region of memory that is shared by cooperating process is established in this shared memory system. That's what we have discussed in the previous session, right? You can see here, there will be a region of memory that is shared by the cooperating processes established in the shared memory system. This is the region which is shared among the processes, cooperating processes. Okay, this region of memory that is shared by the cooperating processes is established in shared memory system. Okay, then the processes then exchange the information by reading and writing data to the shared region. That's what we discussed in the previous session. Okay, a region of memory that is shared by the cooperating processes established, and processes then exchange the information by reading and writing data to that shared region. Okay, and shared memory region resides in the address space of the process, creating the shared segment. Okay, you can see in this example here, the process A wants to communicate with process B. That means that the shared memory region will be region will be created by the process A in its address space. Okay, shared memory region resides in the address space of the process, creating the shared memory segment. Here the process A is the wants to communicate with process B. So the shared memory region will resides in the address space of process A. Okay. Other processes that we wish to communicate using the shared memory segment must attach it to their address space. Like if the process B wants to communicate with process A, okay, that time the process B also must attach that shared memory region to its address space. Okay, here this memory is shared memory region will be attached to the address space of process A as well as process B. That means both the process A wants to communicate with process B and process B wants to communicate with process A. Okay, here the shared memory region resides in the address space of the process, creating the shared memory segment, and other processes that are wish to communicate using this shared memory segment must attach their address space. Okay, both will be having that shared memory region will be shared by the both processes which wants to communicate with each other should attach that shared memory region. Okay, usually the operating systems will try to prevent one process from accessing the other process's memory. It is operating system will not allow one process to access other processes memory. Okay, here the shared memory requires that two or more processes agree to remove this restriction. Okay, if it is shared memory system means those the systems which wants to communicate by using that shared memory, which wants to cooperate, the systems which are cooperative processes, those process should agree to remove these restrictions. The restriction is what? The operating system will not allow one process to access another process's memory. Okay, that is about shared memory system. Okay, next we can explain this shared memory system, okay, or cooperating process by considering the producer consumer problem. Okay, very important it is. We can discuss this cooperating processes by using this producer consumer problem. Here the producer produces information and that is consumed by the consumer process. Okay, you understand here there will be two processes here. One is producer, other one is consumer. Producer who produces the information is called producer. Okay. The consumer who will be using that information is called consumer here. Okay. Producer produces the information that is consumed by the consumer process. Okay. We can say an example if you take for this producer consumer, compiler produces a assembly code. Okay. Which is consumed by the assembler. Okay. Whereas assembler in turn produces a object modules. Okay. Which will be consumed by the loaders. Here the producers are who? Producer compiler is a producer which produces the assembly code. Okay. Who is the consumer here? Consumer is the assembler who consumed that produced assembly code. Okay. Consumer is the assembler here. Whereas the assembler again it acts as a producer which produces the object code models. Okay. Which will be consumed by the loaders, where the loaders will become consumers here. Okay. This is the producer and consumer. Producer means who produces the information. We call it as producer. Consumer means who will be using that information will be called as consumer. Okay. Where in this, if you discuss this producer consumer problem, uses the shared memory. Producer consumer problem will use shared memory. So here the data will be shared, data will be stored in the shared memory. Okay. Producer is different process and consumer is different process. Okay. And to allow the producer and consumer process to run concurrently, there must be a buffer of items. Okay. That can be filled by the producer and that will be emptied by the consumer. Okay. Here producer will be producing some information, some data items, the producer will be producing it. That data items will be storing in the buffer. Okay. This buffer, where the buffer will resides, the buffer will resides in the shared memory region. Okay. Where the both producer and consumer process can access that region. Producer will produce the items and will store in the buffer. Okay. That will be consumed by the consumer. Okay. That items will be emptied by the consumer. Okay. The buffer will reside in the shared memory region. That's what we discussed. Okay. Here the producer produces the information and that produced information will be stored in the buffer. That buffer will be placed in the shared memory region where both the producer and consumer can access that buffer. Okay. And the producer can produce one item while the consumer is consuming another item. Okay. When the producer produces an item, that item will be consumed by the consumer. By that time, the producer will produce another item. Okay. The producer and consumer must be synchronized. Okay. So that the consumer does not try to consume the item that has not yet been produced by the producer. Okay. The consumer should wait until the producer produces the item. Okay. Until the buffer is empty, at least one part of item place is empty, the producer should be waiting. Okay. Consumer should be waiting until at least one item should be placed by the producer to the buffer. Okay. So that the consumer can access the buffer and consume the product. Okay. In this way, the producer and consumer should work in synchronized manner. Okay. The producer can produce one item while the consumer is consuming another item. Okay. The producer and consumer must be synchronized so that the consumer does not try to consume an item that has not been produced by the producer. Okay. That is nothing but producer consumer problem. Okay. Here we have said that buffer. Here the buffer will be of two types of buffers can be used here. One is unbounded buffer, other one is bounded buffer. Unbounded buffer places no practical limit on the size of the buffer. Okay, in unbounded buffer, there will be no limit for size of the buffer. Okay, where the consumer may have to wait for the new items, but the producer can always produce the new items because the buffer will never fill. Okay, there is no limit for the buffer. Once the buffer is full, the producer can wait until the buffer is empty. Okay, free. Okay, in this unbounded buffer, there will be producer need not wait at all. He will be keep on producing the items. Okay, the consumer may have to wait for new item. Okay, if the producer not produce not even a single item, that time the consumer can wait in the unbounded buffer. Okay, understand that unbounded buffer means here unbounded buffer places no practical limit on size of the buffer. Okay, there will be no limit for the buffer size. So the producer can produce n number of items. Okay, because buffer will never fill. Okay, and next we have another type of buffer is bounded buffer. Here, bounded buffer assumes that there is a fixed buffer size. Okay, bounded buffer will have some fixed size will be there. So the consumer must wait if the buffer is empty. Buffer is empty means the consumer should wait. Whereas in bounded buffer also, the buffer is empty, the consumer should wait. Okay. Whereas in bounded buffer, the producer must wait if the buffer is full. Okay, here in unbounded buffer there will be no chance that buffer will be full. Okay, buffer there is no size limit for the buffer. Okay, so there will be no situation that the producer will wait in the unbounded buffer, whereas in the bounded buffer the producer must wait if the buffer is full. Okay, until he should wait that the consumer consumes an item from the buffer. Okay, here in this bounded buffer, the customer must wait if the buffer is empty, whereas the customer must wait if the buffer is empty even in the unbounded buffer also. Okay, if there is no items in the buffer, obviously the customer has to wait until the producer produces an item. Okay, this is the producer consumer problem. We'll see this, and we have discussed, right? Here the producer and consumer problem will be using the shared memory, right? Shared memory will be using here. This is a bounded buffer problem, producer consumer bounded buffer problem. Here we have a fixed size for the buffer. Here we are assumed that the buffer size is 10. Okay, and shared memory region, we have some set of data that is defined buffer size, that is 10, and we have a defined structure for the item here. The item buffer of buffer size. Okay, we are declaring an array here. Okay, of item. Okay, and the size of the array should be buffer size. Buffer size is a constant, that is 10. Okay, and here we are declaring in shared memory the in and out variables. Okay, in is 0 and out is 0. You can see here in this here the following these variables reside in the region of memory, shared region of memory by the producer and consumer processes. Okay, we'll see how bounded buffer can be used to enable the process to share the memory. Okay, here in this shared memory, that information is stored here. Okay, what information is stored in here in this shared memory? The size of the buffer. Okay, and item we have declared as an array called buffer array, and the size of the array is buffer size. And here we declared two variables. In is equal to 0. In variable in we initialized with 0. Variable out we have initialized with 0. Okay, the shared buffer is implemented as a circular array with two logical points. Okay, we will implement this shared buffer as a circular array. Okay, circular array with two logical pointers. One is in, other one is out. Okay, these two are logical points. One is in, one is in, other one is out. Okay, the variable in points to the next free position in the buffer. Okay, and out points to the first full position in the buffer. Okay, the buffer is empty when in is equal to out. Okay, and the buffer is full if there is a situation like in plus 1 mod buffer size is equal to out, that time the buffer is empty. Okay, we'll discuss that in detail. Second. Okay, this is code for the producer process. This is code for the consumer process. Here it is given that the shared buffer is implemented as a circular array. Okay, how the circular array looks like? It will be like this. Okay. Okay, and it will be having different items. This is 1, 2, 3, 4, okay, 5. Okay, I am just taking that my buffer size is 5. Okay, and here they have given that the shared buffer is implemented as a circular array with two logical point in and out. Okay, in here the variable in is points to the next free location, free space. Okay, in always will be points to the next free location. Okay, okay, we'll draw here. That means, okay, I have one item in the buffer. Okay, buffer size is 5. 1, 2, 3, 4, 5. Okay, in always points to the next free location. We have in buffer, there is one item. Okay, always in will points to the next free location. That is this. Okay, this is in. Okay, and always the out will points to the first full position, that is this out will be points to the first full location. Okay, this is about in and out. Understood, right? Like this, the producer will produce an item, he will fill into the buffer. Okay, next in will points to the next location, next producer will produce another item, that will be points to the next location. Okay, like that will be filling this buffer, and consumer will be always points to the first filled location. Okay, consumer will consume this item first, next it will points to next item. Okay, if both in and out both points to the same location, means the time the buffer is empty, no items in the buffer. Okay, understood this? Okay, we'll discuss the code for the producer. Okay, here we have the item next produced. Okay, producer process code we are seeing here. They have given that while is true. While true means always this loop will be get executed. True means while of 1. While of 1 means the control will go inside the loop, it will start executing. And here we have a another while loop inside this while, that is while in plus 1 mod buffer size is equal to out. Okay, consider that buffer size is equal to 5. Okay, buffer size is 5. In is in the shared memory we have stored that in is equal to 0, right? In value is 0, in is 0, out is 0. Okay, buffer size I am considering as 5. Okay, in plus 1 mod buffer size is equal to out, that time we should not do anything. That means that there is no free buffer. Okay, in is 0. 0 plus 1 is 1. 1 mod buffer size 5 is 1. 1 is not equal to 0. Out is 0, right? So 1 is not equal to 0. 1 is not equal to 0. So this loop is false. Okay, so control will come here. Okay, we have here semicolon. Okay, these statements will not come under this while loop. We have a semicolon. Okay, so control will come here. Here we have the statement is buffer of in is equal to next produced item. Whatever the item that produced by the producer will be stored in the buffer of in. In is what? In is 0 initially. So 0 arrays 0th location, the new item which is produced by the producer will be stored. Okay, we just assume that 10 is produced by the producer. So in the array's first location, it is stored. Okay, in this first location, it is stored. 10 is stored. Next, we are updating the in. In is equal to in plus 1. In is what? 0. 0 plus 1 mod buffer size. Buffer size I just assumed as 5. Okay. 0 plus 1 is what? 0 plus 1 is 1. 1 mod 5 is 1. So in value get updated to 1. So again control will go back here. The while is true. So it will check, it will execute this while loop. While loop here, the in value is 1 now. 1 plus 1 mod buffer size is 5. Okay, that is 2 mod 5 is 2. That is not equal to out. Out is 0. So control will comes here again, and the producer will produce another item that will be stored in the arrays at index 1. Okay, in one place it will be stored the next item which is produced by the producer. Like that this loop will be executed until the in is equal to 5. Okay, once the in will become 5, the time control will go back here, it checks the condition. Okay, that is the in will become 4. So here the condition will be checked as in plus 1, that is 5. 5 mod 5 is 0. So it is equal to out. Okay, so that time it won't, the control, that means there is no free space in the buffer. Thus the producer should be in the waiting until the consumer consumes an item from the buffer. This is the producer process. Whereas consumer process, you can see here we have declared an item called next consumed item, and we have a while true. That means if it is true, control will go inside the loop. Okay, while of in is equal to out. In is initially what is the in? In is what? Initially it was 0 and is equal to out. If in is equal to out means the control will be in this loop itself. Okay, that means in is equal to out means there is nothing to consume. That means complete the buffer is free. Okay, but now after executing this producer process, the in value become 5. 5 is not equal to out. So control will comes here and it executes these two statements. That is next consumed is equal to buffer of out. Always out will be always points to the first location. Okay, first location we have 10, item 10. So that will be stored that will be stored in the next consumed. Okay, then we will update the out. Out is equal to out plus 1 mod buffer size. Out is what? Out value is 0. 0 plus 1 mod buffer size is 5. So 1 mod buffer size is 5. So out will become 1 now. So control again go back here. In is 5. Okay, out is 1. So in is not equal to out. So it comes here. Consumer will start consume it again. Okay, so until the out will become 5, it will be keep on consuming it from the buffer. Consumer will be consuming from the buffer. Okay, once in is equal to out, the control will be stays inside this while loop only. That means that in is equal to out means there will be no item to consumed by the consumer. Okay, nothing to be consumed by the consumer. Okay, so control will be there. That means that consumer is in waiting place. Okay, that's about the producer process and consumer process.